All right, this is Coach Williams, and we are going to start notes for 8.1, actually 8.1, 8.2, and 8.3. These sections all kind of go together and are related to each other, so we were going to go ahead and give you all the notes up front before we did the practices on these. We're going to talk about quadratic functions. We're going to talk about the types or the shape of the graph that it makes. We're going to learn about vertex, what the vertex is, how to find it. We're going to learn about the axis of symmetry and what that is, how to find it. And just basically some general knowledge and characteristics of quadratic functions. We've already learned how to factor some of these. So when we get into finding zeros and graphing these things, and we're already going to have some background knowledge in quadratics just from the previous chapter, chapter 7. So to get started, let's talk about the vocabulary terms here. A quadratic function. What we're going to refer to with quadratic functions is anytime we have a function, and I'm going to write this two ways. We're going to have it as f of x, and that f can be any letter. That could be G, H, L, whatever. I mean, it could be any letter that they may put here, but some function of x, basically, equals, and what we're going to end up with is an ax squared plus bx plus c. You'll notice this as standard form for a quadratic polynomial, as we mentioned in our previous lessons. And what we're looking for in a quadratic is the highest degree term is going to be a square. Okay, so that's what we're looking for when we say we're dealing with a quadratic function. And this again is also when a does not equal 0. Okay, one other way you could write this, we could always exchange the f of x for y. So this could be y equals ax squared plus bx plus c. Okay, so we're talking about quadratics. That is what we're talking about in this particular case here. A polynomial where the highest degree term or highest degree monomial is an x squared, or a variable raised to the second power. All right, the next term, parabola, and a lot of people refer to this as parabola, and that is not a disease, and it is not the way you pronounce this, but if that helps you remember this, parabola is just the shape or the graph of the quadratic. So this is just going to be the graph of a quadratic. All right, so the graph of quadratic is a parabola. And if we were to draw a few examples of that, this is your x-axis and y-axis. What you're going to end up seeing is you may see a graph where the line or the curve, it's actually a curve, is going to come down like this, and it's going to curve back up. So you would have something that looks like that. That might be a graph of a quadratic or a parabola. The parabola just refers to this curved shape that you see here. You may see a graph where it's off, to the side here, doesn't cross either one of the axes, the x or y, and then you may have a situation where it does, and it could point down as well. So you may have a situation where it points down, and these are just different, quadratic equations being graphed. And you also may have it maybe a little skinnier. You may see it where it's real skinny, or you may see it where it's real large width-wise here. It may be a very wide graph. In all these cases, you have the shape of a parabola, which is the graph of the quadratic. The next thing you're going to learn here is the vertex. And the vertex is simply going to be the highest or lowest point on the graph of the quadratic. So in this case here, the lowest point of this parabola would be this point down here. The lowest point here would be right on the y-axis there. The lowest point would be right there. In this case, it would be a highest point because this graph opens down. And so you may see the vertex being right there. And then obviously this is just a little, not that great of a graph of parabola, but you'd say it'd be right there. All right, so these are the vertex, or this is the vertices. This would be the vertex, that's the vertex, that's the vertex. Okay, these are all the vertex locations, and they're going to be coordinates. So there'll be an xy coordinate whenever you see this. So this would be a xy coordinate when you see a vertex. Okay, so that is what vertex is. When you're dealing with a quadratic, it's going to be the highest or the lowest point on the parabola. And then we're going to talk about the axis of symmetry. The axis of symmetry is going to be a vertical line. You may see this abbreviated to axis of symmetry. The axis of symmetry is going to be a vertical line. Vertical line that divides the parabola into two equal halves. It divides the parabola into two equal halves. If we're looking at these examples that we had here, you're going to see a vertical line. It's going to go through the vertex. Okay, vertical line here coming down. Vertical line on the y-axis there. This would be a vertical line coming down through there. Here you'd have a vertical line coming down through there. What it does is it divides this parabola, or this one, or this one, or this one, or this one. It divides them into two equal halves. If I were to fold this paper on this line, then this would match up with the left side. The right side would match up with the left side, or vice versa. Okay, so it's a vertical line that divides the parabola into two equal halves. And you'll see these. It's going to go right through the vertex, because the vertex is the point at which it changes direction. And so you're going to see the axis the axis of symmetry is going to be the x value of the vertex. We'll see that again in just a minute as we move along. The question was asked before, well, Coach, can we see it? Function looks like this. And we cannot do that because this is not a function. What's our real simple quick test that we use to find out if something is a function or not? The vertical line test, yes. And this would not pass the vertical line test whatsoever because it crosses in 2 points. And so this one is not a function, so you won't ever see this happening. I'll go ahead and give you a good not going to happen sign. How about that? All right, so that's not a function. It will not pass the vertical line test. You're only going to have parabolas opening up or opening down, and we'll see the relationship to why they do that here in a minute. Okay, some characteristics. Let's move on to the next part here, core concepts. Characteristics of quadratic functions. The parent quadratic function is just f of x equals x squared. X squared doesn't have any coefficient in front of the x squared. There's nothing after it, so there's no other values, no x to the first degree term. There's no c term. So this is basically just it's the parent down. It's a stripped down version of just x squared. And when you see this parent function, this is the parabola that you're going to see. It's positive, so it opens upwards. Okay, it goes through the vertex is 0, 0, goes to the origin. For the vertex, the axis of symmetry is going to be the y-axis. Okay, now, as we move along, you'll see more examples of this, but as we add more components to this x squared, if we add a b term, if we add a c term, if we add a coefficient in front of the x squared, all right, that's not 1. If you add, like, if it's 2 or 3 or negative or whatever, as you add more components to this, it basically is just going to change the shape a little bit. It may be skinnier, it may be wider, it may move the location of the vertex up or down or left and right. But that's going to be all of the pieces that you would add to the parent function. So they're all transformations, and you'll see that in the next line here. The graphs of all other quadratic functions are transformations of the graph of the parent quadratic function. So all we've done is we've just modified the parent function, and we've either moved the graph up, down, left, right, made it skinnier, made it wider, whatever. All right, so now this is kind of a repeat of what we've already written down in our vocabulary terms, but the lowest point on a parabola that opens up, or the highest point on a parabola that opens down, is the vertex. Okay, and the vertex of the graph of f of x equal to x squared, the parent function, this is the parent function again, is going to be the origin at 0, 0. So you'll see that right there. That's at 0, 0. All right, the vertical line that divides the parabola into two symmetrical parts or two equal halves is the axis of symmetry. Okay, we already determined that. We gave you an example of that as well. The axis of symmetry passes through the vertex. For the graph of f of x equal to x squared, the axis of symmetry is the y-axis, or it's just x equals 0. Remember we said that it's the x value of the vertex. This is the vertex. So we just take x equal to the x value in the vertex, and that's going to be my axis of symmetry. Okay, let's move on to the next part and just kind of identify some of the characteristics of these graphs that they give us on 1 and 2. On this first one, what do we know about the vertex? Where is the vertex on number 1? What is the coordinate for the vertex on number 1? We're going to go -1 and then up 1. It's this point right there. So it's -1 and 1. -1 and 1. Okay? What about the axis of symmetry? What is the AOS? What did we say about the axis of symmetry? It was going to be the x value in the vertex, the coordinate for the vertex. So we would just say the axis of symmetry is equal to what? -1. All right, so if we're drawing our line here, the axis of symmetry will go through the vertex. So there's our axis of symmetry. All right, and then what about the y-intercept? What about the y-intercept? Where is this crossing the y-axis? Should be 2 right there, right? The y-intercept is at 2. Okay? And then we can talk about when the function is decreasing and when the function is increasing. We're always talking about this as we move from left to right. So we're moving from left to right. When is this function decreasing and when is it increasing? It's decreasing on this side over here, right? On the part before you get to the vertex. That is decreasing. Right? And then as you go past the vertex, now we are doing what? We're increasing. Okay? Moving from left to right, the function values are getting smaller, 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 smaller. At the vertex, it's going to change and become larger, 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 larger. Okay, so we're decreasing and increasing from there. And the vertex, or the axis of symmetry, is going to be the point at which this changes from decreasing to increasing, or maybe from increasing to decreasing if it's flipped. We'll see that in a minute. So the way you could write that is that it is decreasing, okay, as long as x is less than the vertex value, right? So as long as x is less than -1. And then it's increasing as long as x is greater than -1. Does that make sense? That as long as x is less than the -1 on this side, the function is decreasing. But as long as it's greater than -1, the function will be increasing. Okay, so anything less than 1, it decreases. Anything greater than 1, it's increasing. So you kind of see where that is going to be taking place. Okay, number two. Where is the vertex for this parabola? What is that value there? Yeah, it's at 1, 2, 3, 1, 2, 3, 4. So we're at 3 and 4 as the vertex. The axis of symmetry is always this x value right there. So where's the axis of symmetry going to be? X equals 3. Right? So we're going to have our axis of symmetry going through right there. And then we've got the... at this point, we don't know exactly where it's going to cross down here on the y-axis, so we're not going to be too concerned about that. Where's this thing increasing and decreasing? Well, it's increasing on the left side here before it gets to the vertex, and it's decreasing on the right side of the vertex as we go from left to right. Okay? All right, let's turn the page. We've talked about the zeros of the function in the past, and so this should be just kind of a repeat of previous vocabulary terms. The zero of the function is going to be the same thing on quadratics as it is on our other polynomials that we've dealt with. So the zero of the function is just going to be simply the x-intercept. You could call it the root. You could also say it's the solution. And it's just going to be basically where the graph crosses the x-axis. Okay? And so if we were to demonstrate that, we put a graph out here to the right. You have your x and your y axis there. If I were to draw a parabola coming through here like this, and let's say I were to draw another one up here like so, and maybe I had one more that came in like this right here. Okay. How many roots or zeros of the function are in the blue parabola, or the function in the blue? How many would we have there? We would cross the x-axis how many times on the blue parabola? 2 times. So we would have one there, we'd have one there. So there would be 2 for that one. What about the pink one? The pink one would actually only touch it, so it would still have a root. There would just be 1. And then how many would the red have? The red would have 0. That doesn't touch the x-axis, so there are no zeros or roots or solutions for the red, function that's represented there. All right, let's look at a few examples finding the zeros of functions. And there's going to be multiple ways that we can, solve these, the zeros of the functions from in these next four practice problems. I'm going to demonstrate a couple of ways we could do that. If you were to take this first one, and solve it like we have in the past where we just isolate the variable, you could do it that way pretty simply. Remember that anytime we're finding the zeros of the function, it just means we're going to set the function equal to 0. So instead of y, or instead of f of x, or instead of n of x, or p of x, we're just going to put a 0 right there. We're going to set that whole function equal to 0. All right, now, there's a couple of ways we could do number one. We could say, well, let's just get x by itself, and we're going to have if we moved the x across move this x across, or we added x squared to both sides, we'd end up with x squared equals 1, because it would change the sign as it moved across, right? We'd have a positive x squared over here plus the 0 that we had, but that would just become x squared plus 1. And if we took the square root of both sides, right, to solve for this, when we take the square root and the square root, then we'd end up with x equals the square root of x squared is x. The square root of 1 is actually a positive or a negative 1, because the negative 1 times a negative 1 equals 1, and a positive 1 times positive 1 equals a 1, and so that would be my zeros of the function. There's also another way you could do this. How many of you recognize if I had just moved everything across to the other side, or simply multiplied everything by negative 1, I'd end up with a positive x squared minus 1 equals 0. Does anybody remember what this looks like from our previous lessons? How about a difference of squares? Right? You have a perfect square minus a perfect square. So that means we take the first one, square root of the first one, plus the square root of the last one, times square root of the first one minus the square root of the last one. Again, we set those equal to 0. And we know from our previous practices, and lots of it, hopefully, that x plus 1 we'd set to 0, x minus 1 we'd set to 0, and we would still end up with the same answer. We'd have a plus and a minus 1. All right? And then, furthermore, we could graph this or even look at a table, and we could find where the y equals to 0 or where it crosses the x-axis. So if we graphed this, we would have something like this right here. Okay? Our graph would look something like this. We would have a graph that would come up here and back down. And so our zeros are going to be where it crosses the x-axis, which is at 1, and negative 1. Those are going to be the zeros of the function, right? We're going to cross right there, cross right there. And so you could look at the graph itself and see where it crossed the x-axis. It crosses right on a 1 and a negative 1. And so that would be the zeros of that function. On number 2, again, we could solve this one. Let's solve this one using the difference of squares. If I were to multiply everything by negative 1, right? Except that I'm going to go ahead and set that equal to 0. So I'm going to multiply everything by negative 1. I'm going to have 4x squared minus 16 is equal to 0. Now just flipping the sides. You can move it everything to the left side if you wanted to do it that way. Either way you look at this, we're just changing the sign of everything there. And the 0, it doesn't have a sign, so we don't have to worry about that. Okay. So now this is a difference of squares. What do we have? We have 4x squared. So we take the square root of that, and we get 2x. We're going to add the square root of 16, which is 4. And then we're going to do a minus version of the same thing. So we'll have 2x minus 4. Again, still equaling 0. Okay. We're going to set these both equal to 0. I'm going to do 2x plus 4 equals 0. I'll move this 4 across to the other side. So I'm going to take that across. That makes it negative. I'm going to divide by 2. And then I'm going to get x equals a negative 2. Anytime you deal with a difference of squares, you know that the other one is just going to be what? If one's negative, the other one's positive. So I'm going to have an x equals a negative 2 and x equals a positive 2. Okay, so those would be my roots. Now, if I were to put this in the calculator, and that's something I'm going to spend just a second talking about. When you're dealing with quadratics, especially when it comes to test time, when it comes to STAR test for Algebra I, anytime you're dealing with quadratics, the calculator can be your best friend. Okay, so on the calculator, we can actually put in this quadratic, and we can graph it, and we can look at the table, and we can find the zeros, and we can find the vertex, and we can find the mins and the maxes, etc., etc., etc. All right, so what we're going to do here is we're going to put in this function in y equals. So I just went to y equals on my calculator. I'm going to put in, and I'm going to put this version in once I've already changed it. It's not really going to matter much, but once I've changed this, I'm going to put in 4x squared minus 16. So I'll have 4x squared minus 16. That's my graph. I'm going to show you the graph, and you'll see it looks like this right here as my calculator is taking its time. You'll notice that it passes through -2 and +2 right there. If you can see that, it passes through the -2 and +2 on the graph. Now, if I wasn't real sure that it passed through those exact numbers, I could go into second graph, and that takes me to my table. And let me reset my table settings here real quick because I was doing some other things earlier. All right, so I could look at my table, and all I really want to do is find where y equals 0. Isn't that the x-axis? The x-axis is when y equals 0. So if I find where y equals 0, then I look over here, and x is a -2. Voila, -2. And if I go down to the other 0, I have x is equal to a +2. And that's what we got on our calculations before. So you can find the zeros of the function looking at the graph. You can find the zeros looking at the table. You look for y equals 0. Or you could actually solve it algebraically here as we did in the beginning. All right, and if you notice here, if you want to just create you a table and say you didn't want to do all this, you just created you a table here, and you look for where y equals 0. Let's say we started at -3, -2, -1, and then we went on down the list here. We would have 20, and we'd have 0, and we'd have -12, -16, -12, 0, and then 20 again. You can look at these locations where y equals 0, and that's what we did right here. We just set it equal to 0. Look at y equals 0, and those would be your zeros of the function. Can anybody tell me from this table of values where the vertex is? Where's the vertex? On just looking at the values on the table, what would the vertex be? Anybody know? How about right here? That's the lowest value. Remember, it opened up, right? If we go back to our graph, this thing opened up to the top. It opened upwards, right? So the vertex is going to be at the lowest point. If you look at these values, they get lower, 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 and here's the -16, and they go back up again. So this would be my vertex. So that would be my vertex at that point there if I put in this version, right? If I put in the negative version, I'd still get the same zeros. The vertex would just be positive. This would be a flipped over. Okay, so now let's move on to the next one. We've got nx, which doesn't mean anything to us really. We can change that to f of x. We can change it to g of x, h of x. It doesn't matter. But it doesn't really matter at that point either because we're just changing it to a 0. Okay? So we know this is going to be a difference of squares. And or it looks like it would be if I changed everything. Or if I just moved the x squared over, I'd have x squared equals 64. I'd take the square root of both sides. Again, solve this many different ways as you will. And then x is going to equal plus or minus 8. Okay, it's going to be a positive 8 or a negative 8. Okay, same thing with this one here. Same thing with this one here. I could move this 9x squared. I could just move it across. That's becoming a 0. I can move that across, making it positive. So it would be 9x squared plus 1. If I divided both sides by 9, equals 1, sorry, equals 1. If I divided both sides by 9, then I would have x squared equals 1 over 9. Well, I can still take the square root of both sides here. Take the square root of x squared, square root of 1 over 9. And so x, in this case, would be equal to 1 over 9, taking the square root of that, would be a plus or a minus 1 over 3. So we have positive 1/3 or negative 1/3, and I could solve it just like that. I could solve it as a difference of squares. I could solve it as taking the square root here. I could also look on the calculator, and I could find the value there. Now we would need to do some work there if we want to find on the calculator, because it would be in decimal form on the calculator. We'd have to look for 0.3333 on the calculator. But anyway, you could solve these multiple ways whenever you're trying to find the zeros of functions here. All right, let's look at number 5 and 6. Sketch a parabola with the given characteristics. All right, the parabola is going to open downward, meaning that if I have a function, this is going to open downward. This is opening downward, and this opens upward. Okay, the arrows are pointing up on this one. The arrows are pointing down on this one. We're going to find a relationship to these here soon, but it wants us to graph one where the parabola opens downward, and the vertex is at 0, 5. So that's going to be my first point that I'm going to plot is 0, 5. So I'm going to come here. I'm going to go up 1, 2, 3, 4, 5. I'm already at 0. So I'm going to go up here to 5, and I'm going to plot my point. That's going to be my vertex. And remember, when I graph a parabola, the left and right sides of the vertex have to look the same. So it would be to my advantage to pick a couple points out here. Let's just say I'm going to pick this point over here, and I'm going to pick this point over here. Notice I am 3 to the left, I'm 3 to the right, because these points have to mirror each other. And then I'm going to have a parabola coming down like so. Parabola coming down like so. And you'll notice that that's pretty close to a axis of symmetry. They're not exactly the same, but your graph is opening downward. The vertex is at 0 and 5. Okay, what about number 6? It says the lowest point on the parabola is 0, 4. Well, if the lowest point on the parabola is at 0, 4, it means everything else must go upward. And so if that's the lowest point, I'm going to go to 0, 4. 1, 2, 3, 4. And that's the lowest point. Everything must go upward from there. So I'm going to pick a couple points here again. Same distance away from the y-axis. So I'm going to pick a couple points. And I'm going to go like so. And like so. So my parabola would look something like that. It opens up because we know it said lowest point. And it was at 0, 4 for the vertex. Okay, let's move on to 8.3 notes. 8.3 notes, we're going to talk about max and mins, maximum value and minimum value. All right, and what we're basically talking about is the vertex, or the value at which the graph gets down the lowest or goes up to the highest. All right, so that's what we're going to do with max and mins. We're talking about if it's a max. If it's a max, we're talking about the y value of the vertex when the parabola opens downward. Okay, if the parabola is opening downward, then we have a max. So this would be downward. Okay. And the minimum is just going to be the opposite of that. Okay, the minimum is going to be the opposite of that. So this is going to be the y value of the vertex when the parabola opens upward. Okay, so when it opens upward, right? So if we have our graph over here, we're going to have a graph like so. There's my y, there's my x. If I have a max, The maximum is going to be when the parabola opens downward. So if I have a max, here's my parabola open downward. I'm talking about the point here. Okay, that's going to be a max. If I'm talking about a minimum value, that's going to be when the parabola opens like this, and it's going to be the lowest point here. So that's my minimum value. And again, don't forget, these are going to be x, y coordinates. Okay, they are going to be an actual coordinate value. So you're going to have an x and a y value at these locations. Okay, so you have maxes and you have mins, and it's just referring to the y value of the function, and in reference to if they open up or down, you'll be able to find your mins and maxes. Okay? All right, and then let's talk about a few core concepts, and we may try to wrap these notes up for the day, and we'll finish these up tomorrow. But let's talk about a few more core concepts. Graphing f of x, ax squared plus bx plus c. The graph opens up when a is greater than 0. Okay? So it opens up when a is greater than 0. All right, the graph opens down when a is less than 0. All right, so in this case here, we'll just kind of point back up to a graph that we have. All right, if we point back up to this graph right here, this graph, you would have a negative ax squared. All right, because a would be less than 0. The only way a can be less than 0 is if a is a negative number. Okay, so this is a opens down. Okay, and then this one here, this one's going to be an a is positive. Okay. And when every time a is positive, we know that this opens up. Okay? So you can find out just by looking at the sign in front of the x squared. If it's a negative sign, we know that it's going to open downward. Okay? If it's a positive sign in front of x squared, we know that it's going to open upward. Okay? So those are some real quick tips or things that you can notice about quadratics whenever you're trying to find out if it leads with a negative or if it leads with a positive on the x squared term. Okay, the next thing, the y-intercept is c. Okay, the y-intercept is c. All right, and then it says the x-coordinate of the vertex is going to be negative b over 2a. The x-coordinate of the vertex is going to be negative b over 2a. And the axis of symmetry is x equals b over 2a. All right, so if we're looking at this graph to our right, if we're looking at the graph to our right, then we can see that the vertex here is going to be negative b over 2a, and we just plug in whatever values are here. We would put those into that location, and that would give us the vertex point, okay, or vertex x-coordinate, we'll say. If we wanted to find, just out of curiosity, if we found the vertex, which is the x value, and we wanted to find the y value, then all we'd have to do is just plug that y value back in, and that would give us the y coordinate, or part of the coordinate for there as well. Now, the c, this c outside here, this is going to be the location at which it crosses the y-axis. So let's say this c out here was a negative 3, which is about what this looks like, a negative 2 or negative 3. That's where this graph is still going to cross the y-axis, which is very similar to our linear equations. How many remember what the b term in our y equals mx plus b? The b term was the y-intercept. All right, so now when we get to quadratics, we have to add one more term. So we have an x squared term, we have an x to the first term, and then we have our c, which is our constant. That constant out on the end is still where the graph crosses the y-axis. So when you're looking at this, you can look at the c, you can see where it's going to cross the y-axis. Obviously, the x value will be 0 because it is the y-axis. Okay? All right, those are some core concepts. We will wrap up the rest of these notes and do some demonstrations and examples of this, what we just talked about here, finding the vertex, finding the axis of symmetry, and the y-intercept there. We will wrap that up on the next video, which will be tomorrow. All right, have a great day.